Alright, just in case we need it, we have our calculator here. I'll make sure that I am in degree mode. Good to go, just in case we need it for our trig. So find the measures of the missing sides and angles in this right triangle. Calculate lengths of the nearest 10. So this is calculate the length of the segment BC. So I need to know this side right here. I'm given an angle on the side. If I think about SOHCAHTOA, here's the angle I know. This would be the adjacent side, the side next to it. Opposite the 90 is the hypotenuse, and this is the opposite side. I don't have any information about the opposite side, so I want to use the adjacent, and I want to know this side, so that's my x. So I'm going to use the adjacent and the hypotenuse, which is the cosine. So cosine, after sine, cosine, or tangent is always going to be my degree, so cosine of 55 degrees is equal to the adjacent, 5.3, over the hypotenuse. And to solve for x, you'd multiply both sides by x, and you get x times cosine of 55 equals 5.3, and then we can divide both sides by cosine of 55. So the end result is 5.3 divided by cosine of 55, so 5.3 divided by the cosine of 55 degrees, and you get 9.24. Now let's see, length of segment AC. So this time my x is this, and so I want to use the adjacent and the opposite side to this angle. So adjacent and opposite would be TOA. So this is going to be tangent of 55 degrees equals TOA, so opposite over the adjacent. This time I'm just going to multiply both sides by 5.3. And so x equals 5.3 times the tangent of 55. So it's going to be 7.57. And then measure of angle C. Okay. Angle C, I want to be able to relate two sides. So let's say since I know that this is 7.57, I know that if I relate the adjacent side and opposite side, that the tangent of angle C would relate TOA, opposite side, oops, sorry. This is now the, for angle C, this is the opposite side, and this is the adjacent side for angle C. So that the opposite would be 5.3 over, say, the adjacent side, 7.57. And that when I want to get to my angle inside here, I have to do the opposite of tangent, which is the inverse tangent on both sides. So inverse tangent and C would equal the inverse tangent of 5.3 divided by 7.57. which would be about 35 degrees. And this thing, find the angle of measure M. So for angle M, this is the hypotenuse, this is the adjacent. If I'm doing SOHCAHTOA, the one that relates the adjacent and the hypotenuse is cosine. So cosine of M is going to relate the adjacent side over the hypotenuse. And I would do the inverse cosine on both sides. So M would equal the inverse cosine of 5 over 7.8. Again, you can do that in the calculator. Find the measure of angle N. Well, let's actually go ahead and do that. So inverse cosine of 5 divided by 7.8 gets you 50.13. Well, if this is 90 degrees, that's 50.13. You could do that from, subtract it from 180 degrees, or you could again use trig if you wanted to. So let's say angle N. If I'm talking about this angle now, then this is still the hypotenuse, but this is the opposite side. Opposite and hypotenuse would be sine. So sine of angle N would equal the opposite over the hypotenuse. Do the inverse on both sides. So the inverse sine of 5 divided by 7.8 gets you 39.87 degrees. Let's see, 39.87. If I add that to the 50.13, gets me very close, or essentially that 90-degree angle minus some rounding error. And then length of segment NP. So figuring out that side X. Couple ways you could do it. You have Pythagorean theorem. So if I know these two sides, I could say I could do 5 squared plus x squared equals that 7.8 squared, the hypotenuse squared. I could do that, or I could use my trig one way or the other. Let's see. Let's just do it with Pythagorean theorem. So 7.8 squared minus 25, which is what 5 squared is. Take the square root. I should get about 5.99. Let's see if my trig actually matches up with that. So let's see, that was 50.13 degrees. This would be the opposite side. This would be the adjacent. So opposite and adjacent, that would be tangent. So tangent of 50.13 equals the opposite over adjacent. So 5 times the tangent of 50.13. And I get 5.99 again, same thing. Good. True or false, sine of 30 degrees plus cosine of 30 degrees equals 1. You can plug this into your calculator. Sine of 30 plus cosine of 30 does not equal 1. A lifeguard in a tower 20 feet above sea level. So here's our tower. Here's the lifeguard. Spots a surfer at an angle of depression of 15 degrees. So the angle of depression is 15 degrees. Sorry, angle of depression. Remember, it's from a straight line and then the angle looking down. And since this is 20, I know this is 20. How far is the surfer from the base of the tower? So I'm looking for this distance right here. Here's the surfer. So this would be the opposite side. This would be the adjacent side. So tangent of 15 degrees is equal to opposite over the adjacent. And x would equal, multiply both sides by x and divide, or flip these two, it'd be 20 over tangent of 15. So 20 divided by the tangent of 15 gets you 74.64. So that's how far the surfer is from the base of the tower. And the last section, or at least this module 6 section here, sine of A, SOHCAHTOA. For A, the opposite, well, opposite the 90 is the hypotenuse, so that's always going to be the hypotenuse. So opposite over the hypotenuse would be 8 over 10, so that would be F. Cosine of A, cosine would be the adjacent, so the side next to it over the hypotenuse, so 6 over 10, so that would be C. Tangent of A is going to be opposite over adjacent, so the opposite side, which is 8 over the adjacent side, so that's going to be 8 over 6, so that's going to be A. Now we switch to angle B. So even for angle B, that's still the hypotenuse, but now this for angle B, this is the adjacent side, and this is the opposite of angle B. So sine of B, opposite over hypotenuse. So that's going to be okay. Thanks. Not sure what happened there. Pause. Alright, so we last left off on, where was it, sine of B, so opposite over hypotenuse, that's going to be 6 over 10, so that's going to be C. Cosine of B, adjacent over hypotenuse, that's going to be 8 over 10. And tangent of B, opposite over, so TOA, opposite over adjacent, that's going to be 6 over 8, and that would be B. If you know that tangent of A is equal to 60 over 45, match the other things. So here's A. Tangent is TOA, so opposite over adjacent. So the opposite of A must be 60. The adjacent must be 45. And then if I wanted to do SOHCAHTOA, or not SOHCAHTOA, if I want to do my Pythagorean theorem, I know 45 squared plus 60 squared equals the hypotenuse squared. So let's see. 45 squared plus 60 squared gets me that. Take the square root. That would be 75. And so I can kind of figure all these things out. I might have needed that, might have not. AB, yeah, I didn't need that. AB is 75. BC, that would be 60, so that's A. AC, AC is 45, so that's E. The measure of angle A, let's see, I could do the adjacent and the hypotenuse. So cosine would be adjacent hypotenuse, so inverse cosine of adjacent over the hypotenuse. Gets you 53.13 degrees, or 53. And then if that's 53, 90 plus that, 180 minus that answer. That means that this must be the 36.87 or 37 degrees. And that angle C is at 90 degrees F. And then, let's see, the very last one. Last page is, let's see if we can find it. Problem number 10 and 11. Where are you? Nope, it's on there. Let's see. See if I look at the lefty. Matches.